Hi, I'm David, and I'm currently building out an off-grid solar electric system that is going to power my entire house and garage, and I'm using some Schneider equipment. This is the Schneider XW PRO 6848 inverter with its large circuit breaker box called a PDP, or power distribution panel. This is part 2 in the video series on this Schneider inverter, and there are more videos to come. If you want to see how the installation and wiring went, stick around. Now I'd like to point out right off the bat that I think Schneider did a beautiful job. There's a lot of little details that were thought through and work well together when paired with the PDP. And just so everybody can see it, the PDP has a magnetic cover. We have the manuals inside. This is the DC circuit breaker locations and the AC circuit breaker locations. Now I've actually been running this for the last week, powering my entire house and garage, and I gotta say it's exceeded all my expectations so far. This inverter is listed as a 6.8 kilowatt inverter, but I've run it up over 8 kilowatts every day for turning on things like the dryer and the oven and microwaves and all that stuff, and it's not a problem. It's taking it, and the sine wave's beautiful coming out. I'm not getting any voltage sag that I can see. So it's really a great inverter with that big transformer built in. And what's even more amazing is when I checked the idle draw on this, so the inverter on but no loads, it was only 31 watts according to my Victron shunt, which is over here on the battery bank. Let's go through the installation and wiring together. I cleared off all the old equipment from this wall in preparation for mounting the Schneider inverter and the Schneider PDP. Now this is a piece of fiber cement backer board used for tiles, and I painted it so it just looks nicer. And behind that is 3/4 inch OSB, or oriented strand board, and studs at 24 inches on center. Now, when you're picking the location for this inverter, it does need to be on a fire-resistive backing. Now, it does not have any vents on the side, so you can box it in with things like the PDP, additional inverters, or charge controllers. But you do need to make sure that the bottom and the top are open, because it sucks air in for venting and blows out the hot air at the top. And it does that very effectively. Please keep in mind this is 122 pounds. That's a heavy inverter. The manual says that you need 4 fasteners if you're going directly into studs, or 6 fasteners if you're going into something like 3/4 inch plywood. Now, since these mounting plates that Schneider includes with their equipment, these are designed for 16 on center studs. Since I don't have 16 on center studs, I'm not going to be able to hit every single stud. I'll be able to hit some of them. So I just marked out where the stud center is, and this line is where I'm going to be doing the screws. So the first one that I throw up on the wall, I'm going to get to line up right there. And that way I hit the stud in 2 locations. The other spots, I'm not going to be hitting the studs. I'm going to be going into the 3/4 inch OSB. Once you lift up the inverter and you hook it onto that mounting plate, you can let go and now adjust it left and right just a little bit to get it exactly where you want. The mounting plate has a couple of threaded holes in it, which are made for some number 10 screws, which go through the top flange of the inverter and into that mounting plate. That keeps you from being able to lift it up and knock it off of the mounting plate accidentally. The mounting plate for both are up here at the top. Now the PDP came with a couple of rubber standoffs that are down here on the bottom, which keep the whole PDP plumb with the wall. Now unfortunately the inverter did not come with any standoffs on the back side down here at the bottom. Now once I added this wireway, it did help bring that in line, but there was still some flex in it, so I did add my own shim behind it so that this is now perfectly plumb with the wall. When I was planning out where to position this on the wall, there were a couple of things that I kept in mind. This is the full-size PDP. It can accommodate up to 3 inverters. I have one here, but I did leave enough space so I can add a second inverter off to the side. I don't think I'm going to need a second inverter for running the house and garage, but next year I hope to save up enough money that I can purchase an electric car, in which case I'll add another inverter and a charging port for that. So that's why I left enough room off to the side. I also have room off to this side that I can add a couple of solar charge controllers. Something else to keep in mind, you can't have anything in front of the inverter down here on the floor. If you have anything that's associated with the inverter, it can only come out 6 inches beyond the face of the inverter. So I can't stack batteries on the floor in front of the inverter. I actually have my battery cabinet right here on the side. It's on wheels, and I pushed it off to the side because you need to make sure that there's 30 inches of clearance for the circuit breaker panel. I have the PDP mounted next to the inverter. Inside here, I put in a couple of screws just so that if you pull on this box, it's not going to come off from the wall. Down here is the knockout for the ZAN bus communication cables, and the PDP came with 3 of these bushings. Let's see if they fit. Nope. Alright, so these ones that came with it don't fit in that knockout. I guess they would fit in this one. So this bushing is not helpful for that spot. Let's find another bushing. So I have a bag of these 3/4 inch bushings. Let's give these a try. Alright, so I got the 3/4 inch bushing in there and put this aluminum separator in place. And that's to keep the data cable separate from the power cables. And now we'll just take off this other dead front. So there's a dead front down here and another one here, or panel. Take that off. And now we can see inside to all of its glory. This is the positive bus bar. It's bolted on the back side of the circuit breaker. This is the big 250 amp circuit breaker. It looks like the top side already has a 4-aught lug on there, and it's going up to here, so we'll just pry that off and get it routed over onto this inverter. The negative cable is already connected to the negative bus bar. So we have a grounding bar here, we have another grounding bar here, we have a neutral bar. This is the bypass, so that you can't have both of those going on at the same time. This allows you to bypass the inverter altogether. And then we have our 60 amp 240 volt. Coming down from these circuit breakers are a bundle of 6-gauge wires, and here they are. They have some nice ferrules crimped on the end, and they're nicely labeled. And over here on the inverter, there's this little wiring area, and there's 3 knockouts. Now these look like 3/4 and 1 inch knockouts. The PDP, so this came with some plastic bushings, came with 3 1-inch plastic bushings. So I believe those are going to be specifically for this right here. I'm just surprised the PDP didn't come with that 3/4 inch bushing to go for the ZAN bus cables, the communication cables. That really seems like an oversight, but I don't know. When you're mounting the wireway and the PDP, you need to remove this large panel from each of them. That gives you a huge wire chase running through here. Now they do that because you're not only running 4-aught wires and the AC wires, in this case 6-gauge, but you might also be running multiple sets of those if you have multiple inverters. So great job having the panels. Great job to Schneider for having these big panels that come off and a big wireway. Now over here on the little wiring compartment on the inverter, we've got AC load out, that's grid input and generator input. And these circuit breakers, they're set up and labeled for only one input. And they label it as, let's see, those are the load. Oh, so over there it says grid. So it's labeled as grid. Now the manual says that if you are doing this with the grid and a generator, you have to purchase an additional circuit breaker that doesn't come with it. But if you're doing it purely as off-grid, like I am, then you ignore the grid and you only put into the generator. So these cables that are labeled as grid, they're going to go into the generator port. I'm ignoring the grid. So I'm going to knock out this one and leave the middle one, which would be for the grid. What's notable is that there's only one neutral wire, one white wire, and this one says load on it. Now I checked the manual, and the manual said that there's only one neutral because all of the neutrals up here on the terminal block, they're shared. So let's double check that with our multimeter. So we have our multimeter and it'll beep when we have continuity. So we have neutral, neutral, neutral. So all the neutrals are shared, but it's not tied to ground. So we need a separate ground to neutral bond somewhere else in the system. I checked through my toolbox and I found that my Milwaukee screwdriver has the specialty bit for these screws. See, they fit that area really well. So I put in this conduit, which is going to go down into this wireway, and then I can go over to my load center. So right now I'm bringing in some 6-gauge wire. This is your standard 6-gauge building wire, feeding it up through the conduit. I've already got the ground and one of the hot legs in, and let's do the rest. All right, I'm fishing the neutral wire up to the neutral bus bar, and notice that there's no fish paper or insulation or anything like that up here against the metal. I was kind of surprised by that because other neutral bus bars in other electrical panels that I've worked in will have some kind of insulator. So be very careful that when you push this copper wire in, this one right here, you don't want to go too far. If you go too far, you could short it out to the electrical box. I'm using 6-gauge wire, so 6 to 4 is 45 inch-pounds. This is the Torx screwdriver I use. There we go. So went a little past. Now we're looking at these circuit breakers. Now this can get a little bit confusing because these lugs are attached to jumpers, and those jumpers go up into the circuit breakers. So what we're looking at here is this is hot 1 and hot 2, or leg 1 and leg 2 out to the loads. This is input from either the generator or grid. In my situation, I'm going to have the inverter on, inverter powering the loads, and the generator is not going to go to the loads. Instead, the generator could go through here to the inverter, and the inverter can use that generator to charge the batteries if need be. Right now everything's just off. This is a cool little bypass built in, so you can only do one or the other. And over here I've already ran one hot wire in. This is THHN, which is legal to be installed in these lugs without ferrules. You'll notice that the ones that Schneider installed, they have ferrules on the end, but that's because they're using very fine strand wire. If you use very fine strand wire in this type of lug, it can get loose over time. This type of lug can only be used with coarse strand wire or solid core wire. In this case, This is coarse strand, standard THHN or THWN. It has a lot of different names written on the jacket, so it's legal here. Only if you're using ultra flex fine strand wire do you need to use a ferrule in this type of lug. So now I've got my neutral wire, my hot 2, and my hot 1, and now we need to bring them all over. I don't want them resting across the negative bus bar, so we're going to bring them over and zip tie them. Down each side of this box, there's these little punch outs. They're made for zip ties, so we can easily zip tie these in. And in case anybody's wondering, the zip ties that I'm using are these. I'll leave a link. They actually have the UL on them. I mounted these Pike Industry bus bars. These are 400 amp rated bus bars up on the wall, and I mounted a block of wood in between the two so that there's no way that I can short a wrench from one bus bar over to the next bus bar. It's not the best case scenario. The best case scenario is to have conduit from the PDP to your battery, but in my case, I'm always moving stuff around. I'm always testing new batteries and testing new inverters, and nothing is permanent. This situation's always in flux because I'm making videos for you guys. So I'm gonna run some 4-aught wire from the PDP down through here over to the bus bars. Then I'll attach my battery bank to the bus bars. So let's get a measurement of how long we need our 4-aught wire cut to go from the PDP to these bus bars. So I threw on a wire just very loosely onto the positive bus bar. It's coming through the knockout, and I'm gonna make a nice gentle loop in it up over to the positive side. And I'll mark it there. All right, so if I cut it there, I'll be able to reach to this post. Nice gentle loop up to that positive bus bar, and nothing's being strained. I could come over to the second one and same deal. Now when you're wiring up the DC wires to the battery bank, Schneider says that the wire has to be 4-aught and less than 10 feet in length. Now typically when you're just wiring up a 6.8 kilowatt inverter, you might be using 2-aught wire. But Schneider says you need 4-aught. Now the reason for that is that the surge capacity is so great and the surge can last for so long that this is really more like an 8.5 kilowatt inverter. It's a very conservative listing on this inverter, which I love. I ran a pair of positives and a pair of negatives. To make these wires up, I used 4-aught MTW UL listed wire. Now that is fine strand, but it still has the UL listing. In the past, I've used a lot of welding cable, which is not UL listed. It does do the trick, but in this case, I really wanted to make a UL compliant install. So I used some UL listed wire, UL listed lugs, and I'll leave links for that in the description below. And I hydraulically crimped it on the end. Then I used heat shrink around the fitting, and I think the cables came out really nice. All 4 wires are done, heat shrink, crimped. Now the positive wires are equal length exactly, but they are not equal to the negative, but both negatives are equal length. So you don't have to always have the positives and the negatives equal to each other, but when you're sharing the amps, you do need the ones that are sharing the amps. In this case, the 2 positives are going to be parallel. They need to be equal, and the 2 negatives are parallel. Now what we are actually aiming for is to have equal resistance between the 2 cables. The more perfect we can get the resistance, the better they'll share the flow of electricity. So let's check out here and out here. Looks like we have 6.9 milliohms. And now let's check the next one, 6.8 milliohms. I'm going to be running the wires up through this knockout, and then the wire will attach to the bus bar. But this positive bus bar is just dangling here off the bolt on the back of the circuit breaker. I really feel like if I was to tug on the wire outside the box, that it'd be putting a lot of stress on the back of the circuit breaker, and I don't want to do that. So I want to put some kind of clamp on here right at the knockout so as not to put any stress on the circuit breaker. That was one of these things where I kind of wish Schneider had mounted that on the back just like the negative bus bar is mounted there. I really think if they had put the positive bus bar against the back plate firmly attached and then had some little jumpers, maybe tin plated copper jumpers, coming up to the circuit breakers, that would have made a lot more sense. So because I was worried about that, I decided not to use bushings in the bottom knockouts where the 4/0 wire exits the PDP. Instead, I went and purchased some fittings called service entrance connectors. In this case, I purchased the watertight version. It has a rubber grommet on the inside. Now when I installed it, I was able to run my 4/0 wires through there, and when I tighten down the nut, it shrinks the size of the rubber and holds firmly against the 4/0. So now I can tug on these wires down here, and I know that it is not pulling on the circuit breaker. Coming up here inside the PDP, I've already removed one of the bolts. I'm going to remove another one so that we run our 2 negative wires down to the cable connector. And let's take a look at the positive bus bar. The positive bus bar is dangling off the back of the circuit breaker. And let me look from above here so you can see that. These lugs are made for the charge controllers, and these bottom two with the clinching nut on them, those are for the battery connections. At this point, the wiring's done. I can connect my battery to these outside bus bars, and I've already got the 6-gauge wire running down into this wire way and over into the load center, where it then goes off to the loads. Now, there is one other little detail that I'd like to do, and that is a surge protector. There's a ton of surge protectors on the market. In the past, I've used Midnight Solar, but the manual for the PDP specifically calls out a part number, and that is part number SDSA 1175. And so that is what I ordered. I'll leave a link for this in the description below, but this is the specific surge protector that is recommended for this panel. So here it is. This is the surge protector itself, and then we've got the wires coming off the back for making our connections. All right, so we're gonna add this in. Now the PDP came with another mounting bar that you add the surge protector onto. So I'm gonna go grab that mounting bar from the workbench and we'll install it. So I just noticed something. When this is installed, I'm not gonna be able to get to these flathead screws that are part of the negative bus bar, and that's where you attach the charge controllers to. So if I add charge controllers, I can't get to that. So that's kind of silly. Right now the inverter is on, but in idle. This is not standby, this is idle. We've got 240 volts right there at the circuit breaker, and it's ready to go. It's producing alternating current. So I've got a Victron shunt right there, and connected to it is the app, and let's take a look. 31 watts. Oh my goodness. Only 0.59 amps. Wow. In comparison, each one of these inverters draws 70 watts in idle. The last thing I'd like to point out, for the last week, I've been running this inverter and I haven't done any programming to this. I haven't hooked up a laptop to it. I have not hooked up an Insight Home to it. The Insight Home is actually a device that allows you to hook this up to the internet and do communication through the ZAN bus network to additional accessories. Right now, I'm just using this as a standalone inverter and nothing else. So I didn't need any programming. Right out of the box, it came ready to go. So if you have some kind of off-grid situation, again, no grid tie, no backfeeding, none of that, then you can just use the inverter straight out of the box. You don't need a PDP, you don't need an Insight Home. And I think that's really awesome. I'd like to talk just for a moment about the price tag. As of filming this video, the price of the PDP I think is $1,200. Now that is the PDP that you see here, and this wireway made for one inverter. When I first saw the price tag of $1,200 for the steel box, it didn't quite make much sense to me. But when I found out how much stuff was included, I thought it's actually a fair deal. Not a great deal, but pretty fair. Here we've got a large steel enclosure with a front door that opens. They include 3 circuit breakers. These are 60 amp circuit breakers with a mechanical bypass. It also includes a 250 amp DC rated circuit breaker and several bus bars inside. We have a positive bus bar, a negative bus bar, negative for the batteries and negative for the AC loads, and some grounding bus bars inside. In the past, I've built some of this out myself. For example, on camera here, you can see this long wireway that I installed for some other inverters I used to have. Now this wireway, I think was $300 when I went and bought it years ago. So buying wireways is not cheap. When you buy something that is UL listed, it's very expensive. Fittings will cost you between $7 and $20 depending on the size of them. And the less fittings that you need, like in this case, the wireway just matches up together and the panels come off, the little wireway chase panels. I mean, that is awesome. Saves you a lot right there. In a future video, I will be adding a Schneider Insight Home, which allows communication between the inverter and additional accessories and the web portal if you want to see this online. Now, I'm not great with computers, so I'm a little bit intimidated by the idea of wiring up that Insight Home, but I will be showing all of it on camera, so you'll be following along with me as I learn how to do that in the next video, or maybe 2 videos from now, I'm not quite sure. So if you want to see more on the Schneider install, this is going to be a full series. And I can't wait to do a full-on test of this inverter and hook it up to the accessories and the web portal and all of that. So please stick around, hit that subscribe button, ring the bell icon if you want to be notified for when I release new videos. Thank you everybody so much for watching, and we'll catch you back next time.